I guess one of the favorite programs we use in MTT 250 is the triangular puzzle. And the triangular puzzle looks like this. It's basically the same one they use down at the Cracker Barrel. And the students, they have to program it to machine to a certain depth on each one of these holes. And let's minimize that and let's pull up one of the inventor drawings. This is the design we did here where we designed the part in Autodesk Inventor. This is the IPT model, and we can rotate this around and show you, various things that it took to make this part. Over on this side we have the tree where we're showing the different sketches and the extrusions and things of that nature. And in this section here we have the actual drawing, which is better known as the IDW. And then here's our title block. It shows who drew it, when it was drawn, any kind of dimensions we might have on it. We can zoom in and it'll tell you, what type of material that we're going to be making this out of. It also gives us the dimensions. Right here is showing from the bottom to the first rung being 750 thousandths or 3/4 of an inch. And the distance between the holes in the horizontal direction is 1.1908. From the first rung to the second rung, and then there on out is 1.0313 or an inch and 32nd of an inch. And so what the students, they have to do is they have to first design something and handwrite a program. In our x-axis here we're showing 6.495 or roughly 6.5 inches, and in our y-axis over here we're showing 5.625 or 5 5/8 of an inch. So now, with all that said and done, we will pull up the program itself, which is done with the CNC base, and this is for the Super ProLite 1000 CNC milling machine. Over in this area we have a verification window, and it shows the size of the block. So the first thing I'm going to do is I want to make sure that the size of the block is what we're going to actually be using. Over in this area over here where we have the actual CNC program itself, it was a pretty neat feature. We went ahead and programmed it and plugged in the stock material to start with. That way we would always remember what size stock we're going to be using. And our x-axis is 6.5, so over here it's showing 6.5. And our y-axis is 5.625, which is our height or our vertical direction, and our depth, 0.5, is our thickness. Well, with all that said and done, I'm going to minimize this, click it one time, and we're going to do a verification. If I click on verify and verify program, there's our triangle. Now it's going to go and individually mark each one of these holes 1 through 15. And now it says normal program stop. So that's what we're actually looking for. We want to make sure that our simulation works. If it does not work on simulation, there's no way it's going to work on the milling machine. Over here we also have a little bit more text. It's showing where positioning, showing where hole number 1 is. This happens to be hole number 1. And here's hole number 2, hole number 3, so on and so forth. And then by the time we get all the way down to hole number 15, what it does is it picks the tool back up 3 inches above the surface right here. It takes the X into Y home, which is the bottom left corner, and M2 ends our program. There's a little bit more involved to it than that. We have other things that we need to consider. We're showing an M06T1. If I go to M6, go to Tools and go to Select Library, it shows that our tool number 1 happens to be a 1/8 ML. Okay. Now there's another tool down here a little further down, and that would be tool number 3. So for 3 set up the library under tool 3. It's showing a 1/2 inch hole, which would probably be a little large if you're planning on actually putting a golf tee in there like the actual game was originally designed for at the Cracker Barrel. Anyway, that's pretty much it. Give me a call. Morris M at octech.edu is my extension or email address, and telephone number 803-535-1298. Thanks for watching.